Thank you very much for attending this session, and let's get started. My name is Boris. I'm a developer advocate at Google, meaning I do and I care about all the things that make you successful. And in this presentation, we are going to talk about code generation. The www.apisolutions is my blog, where you can also find nice ways to reach me, and also on Twitter. So, let's get started. Boilerplate code. Who loves boilerplate code? Good. Because it's shit. It's annoying. And it takes usually my time on focusing on less than more important features. And let's talk about the ways how can we remove it. So if you look in all these libraries that you all know and love, they all have the common feature. And you want to take 20 seconds to think what is the common feature of all these libraries. Great. Just if you could please repeat your answer to the respected audience.
They removed the boilerplate code.
Yes, this was one of the reasons that we all love them. They do a lot of work for us. You know, all these libraries, Retrofit that generates the REST calls, Butterknife that assists in finding view by IDs, json parser that we are going to talk about effective JSON parsing, and one of my favorite is DG2 for dependency injection. And as we talk, what's common these libs? They all generate a boilerplate code for us. But the thing is, this is the code that has to be there due to various reasons. This is a duct tape code that connects the interesting code that we want to focus on. And luckily, it's not that difficult. And we are going to see shortly how we can do it by ourselves. So we are going to talk about three more, the most important tools around custom code generation, which are reflection. Who of you have been working with Java reflection? Perfect. Custom annotations. Who have seen custom annotations in life? You are going to see another ones. And to make things interesting, we also want to generate code. And the tool that I'm using and I truly recommend for is Java Poet or any other Java writer. Who have seen Java Poet before? All right, so you are all going to learn something new. Reflection recap. Reflection is part of Java lang reflect package. We get class, method, constructor, classes, and objects. From a class, we can get a methods, field, and etc. Pretty basic, and luckily you, according to the raise that you have, to the hands that you have raised, you all know the subject. So, this is the example that is going to lead us during this presentation. We would like to generate the following extremely interesting Java program that I wrote by myself. Needless to say, it doesn't do anything interesting. Oh no, what does it do? We have a package definition, import for Java string. No difficult, IDs can do it for us. And we have a class having the simple method. And to make things interesting, it gets a string as a parameter. But you should think of this code as an example for the boilerplate code that you don't want to write, and even more important, you don't want to read. So let's see how the tools in Java APIs that we have will assist us to generate this lovely code. And think of this code like adding logs, registering to observer, factory, generating adapters, and etc. So, our second friend in lovely life is something which is called custom annotations, which are the APIs for us to create our own annotations. And if you recall the code for the most important libraries, what does it do? Almost in all cases, except of JSON parser, you need to put some annotations. And I think the most popular one is Retrofit. So here is how we create our own custom annotation. And let's take about 60 seconds to understand the code here. All right, so let's go over the code, which should be really easy. The first line, which is retention, meaning we want to tell Java framework, please keep our annotation on runtime, meaning do not remove it when you compile. The second line is element type method, means that this annotation is going to be for methods, like stuff around various annotations and libraries that you have seen, that you have to put things on top of methods. This is how we define it, public with tag interface, custom method annotation. Just for fun, we can define an idioms inside annotations, because for us they are just classes. And for even more fun, let's define some custom tags. And the one that I put is a priority, which is the enum above, and information. And just for fun, Java provides us a way to put default data, contains data for trading. This was the most interesting thing that I have thought about. So let's add the annotation to our class, which is to our client class. As easy as it gets. We have a bunch of methods. We put our own custom annotation. Sometimes we even use the flags, but we don't have to, because the annotation provides the default values. Great. But now we've seen only one part, how to put things. You know, we put it our own annotation. Let's do something interesting with the values that we have put. And of course, we have annotation processor to the rescue. And in order to understand this code, you need to recall the reflection. And let's take about 40 seconds to understand the code. Please take a look at this. So what we see is a really simple main, but that uses a lot of reflection. What we want to do in the end of the day, we want to go to load the class, our lovely class from the previous slide, go for each method, and if we have a lovely annotation, then let's extract the values. And this is exactly in a slightly Javaistic way what's written here. Meaning, we load class, const as Java poet, sample class from the previous slide. And for all declared methods, we check if the annotation is presenting, is annotation present, and we pass annotation class as a parameter, then we can do cool things about it. And of course, the coolest things are on the last line. If you look, there is a method in italics, generate code with Java poet, that gets method annotation.info as a parameter. If you recall, method annotation info is just a string. So let's recap what we have done so far. What we have done is we defined our own annotation, we put it to our own class, And now we got the value from the annotation. So let's do something cool with it, and which is generate our own custom Java code. How we do it? We will use Java Poet. Basically, Java Poet is a library developed by Square, who are authors of Retrofit, OK HTTP, and other things that you like. That does exactly the same thing. It allows us programmatically to generate Java code. And as always, they provide an excellent and easy API to do it. Let's see how. Basically, it's a Java library for generating Java source files, expressive APIs, and here is the code needed in Java Poet to generate our lovely Boilerplate class that has only one method that, of course, does nothing. And of course, it's just for the sake of example. So please take a look for about a minute to understand the following code, or at least a start of the following Java Poet code. And as I said before, if you want to generate your own Java sources, you don't need to use Java Poet. Any other Java writer will do the work. However, I use it, and for me, it's pretty convenient. So let's take 40 seconds to look at the code. All right. So what does it do? It's pretty simple. Method spec main. It's a method builder from Java Poet that takes a method name as a parameter, adds modifier. I know you all should know what is public in Java. If not, that's all right to ask me later. It's something that returns void, and it has a parameter of name info and of the type string. Pretty easy. And of course, after we build a method, then we need to build a little bit class that surrounds or encloses this method, which is also pretty easy. We just add the modifiers public and just for fun final. We add the method from the previous slide. You see, add method main, and here is the definition from the previous slide. We build it, and to make things interesting, it could be also a good idea to write it after we generate it. So Java Poet provides a really convenient writer. To write it currently, for the sake of the example on the slide, I wrote it to system out. And you don't have to believe me, check it yourself. It works. It's a good idea. So let's recap. What is all about building our own annotation processor? First, we have to create a custom annotation class. Then we have to update our class with the custom annotation from a previous bullet. Then we have to go over our class and extract annotation values during the build, which is usually a good thing, because usually you all should have a strong build machines, so there is no much penalty involved. And the last funny step is, based on the values from the annotations, do all what you want with Java Poet. Because once you have the values, with all the reflection and etc., you are virtually unlimited. Any questions so far? Questions? Great, let's continue. I kind of lied, because it's not all the work that we have to do. Because if you think about it, what have we done so far? So far, in the best case, what we have done is to build our own Java sources, and to make things interesting, we compile it. Let's assume somebody calls either Java C or Jack and Jill or other build tools. But then we have to solve another problem, which is how we connect to the data and to the code that we generated on runtime. because it's not enough just to build the values, just to build the classes. You also have to use them. Basically, this is the reason why we do it. And of course, there are many ways to do it. The key idea to understand, and this is really hard, is to understand that we are talking about two things. We are talking about something which we discussed before. That's a code generation. And a code generation happens on compile time. However, we also the work with annotations, and the usage of the code that we generated mostly happens on runtime. And we are going to see how can we connect in runtime the code that we generated. And let's see how popular libraries do it. Let's start with Butterknife. How Butterknife works behind the scenes. If you recall, Butterknife is a library that does the get view by ID things. Butterknife, behind the scenes, generated classes and loads them on runtime via reflection. But there's a catch here. How does it know which method to load? And the answer is Butterknife and Dart, which is based on Butterknife, have their special naming protocol by which they generate the methods. So when the app loads Butterknife stuff, it looks via reflection, does they have a method with specific names, and then uses them. And this is really nice. However, it has a cost of applying reflection. And cost of reflections could be sometimes notable. Let's see, Retrofit. How many of you have used Retrofit? Good. This is how it works. What Retrofit does behind the scenes is it uses dynamic proxy that we see in the next slides in order to build an object with data and to pass it to OK or HTTP connection. And this is achieved by using dynamic proxy. How many of you have heard of dynamic proxy before? Great. So for the sake of the audience who haven't heard about it, dynamic proxy is the class that builds an object that implements a bunch of interfaces in runtime. And that's why the retrofit adapter returns your interface object. But what it does behind the scenes, as we see here, it uses a dynamic proxy and it intercepts all the method calls. And while intercepting the method calls, the retrofit builds the connection parameters with a precise REST call. And this is why it is genius. And to recap for the ones of you who don't know the dynamic proxy, this is pretty easy. What we need to know is invocation handler, which is a class of Java reflection that knows how to intercept or to catch methods in runtime. Then we can happily create my interface proxy, which has a type of my interface, using the system APIs, which are proxy.newProxy instance. And here we pass the class as parameter with the invocation handler that we defined on the first row. And look at this. This is how Retrofit works. Because in Retrofit, instead of myInterface.class, there is your own interface that you defined to take care of your own REST calls. And let's see. This is the invocation handler, which has only one lovely method, invoke. And when the dynamic proxy is called, then this method is invoked. The invoked method is invoked. And then here, you can do your own lovely code. Either like Retrofit does with all the parameters for the connection, or your own code, if you recall from 10 minutes ago, the code that you created with Java Poet. Or even compiled classes after you compiled the code that you created with Java Poet before. IG JSON parser. How many of you have heard about it? Nice. Because essentially, this is the JSON parser from Instagram. And at the moment, according to a bunch of tests that I asked from developers to perform, this is one of the fastest JSON parsers around. And essentially, how does it do it? It propagates the work from runtime to compile time. So at the moment, if you want to use it, you just need to generate code and generate class, and then add this class to your build, and then use it. This is so far the most uneasy way to do it compared to Butter Knife or Retrofit. However, this tool is genius. For a lot of companies that I know, it solves them most of their JSON parsing problems. And JSON parsing, especially for large JSONs, is known to be hard. Dege2. How many of you have been using Dege2? How many of you like Dege2? Oh, great. I'm in the right place. What Dege2 does is pass a class object in annotation. Thus, it can do all the mapping between classes and interfaces that implement them in compile time. And I have seen companies reducing their upstart time up to 40% when they switched from other solutions to Dege2. Basically, the key idea of Dege2 is to shift naming resolutions for the dependency injection from runtime to compile time. And usually this is a good practice in software engineering, especially with mobile phones. Switch as much as possible from runtime to compile time. Your users will thank you. So if we start to recap, the rule of thumb when you consider your own code generation solution should be around have a useful problem, make your generated code dump simple, because you have to debug it, especially when things don't work. Make your generator super simple, because otherwise people will not use it. And make your connection simple and clear, because making the connection between the generated code and the actual application code is the most trickiest part. In the previous slides, you have seen several solutions how to do it. Speaking of annotation processor, the cost of it is we have many pieces to work together, and it's kind of the addition to the build system. But nowadays with Gradle, it shouldn't be that hard. So we can generate adapters, proxies, inner classes, decorators, and whatever. And I have an open question for you as an audience, thanks to Philip from Avast. What if you take, let's say, 2, 3, 5 minutes, how can you think of a way to dump mapping between a thread and the method that I called by a thread? Meaning, to get the following table: thread ID and method name. For instance, thread 23 on start was called, thread 34 full was called, and etc. By the way, do you understand the problem? Great. So let's take 5 minutes to think about it, and then I would love to hear your solutions before presenting my suggestion. By the way, do you understand the importance of this thing? Sometimes it's a bad idea to block UI thread, so it could be interesting to know who is actually blocking the UI thread. So, ideas from the audience. How can we sort out this problem? That's silence. Anyone have suggestions? I stopped charging money for my solution. Suggestions? Okay. Always hard to be the first, I know.
I know. I just I was thinking about something that when you have when you have the stack trace, when the program is running, all these items should be saved on the stack when you jump from method to method. So you would want to have this when you generate the code or on the runtime. Okay. I'm not that familiar with reflection and all the background on Java API, but I think there might be a way how to get this information from the stack.
Thanks to recap, there is a bunch of APIs when the exception is thrown, and definitely it could be an interesting way to analyze it or to build some sort of a... Why? It depends, because as part of the Java exceptions APIs, all the data that is presented is accessible via methods. So some processing still can be done. Thank you. Any more ideas? We have one idea so far. Come on. Just a moment.
Like you have shown in previous slides, we could just intercept the invocation of the method that we annotated, and there we can get this thread ID that we need.
Great. This is a good way to approach it. Basically, what you are suggesting is to do a dynamic proxy on each method that you want to catch. And then inside the dynamic proxy, inside the invoke of the dynamic proxy, you put the thread stamp, and then you call the original method. That's also a good solution. More solutions from the respected audience? We have two.
You could use aspect-oriented programming. Yes. Yeah.
That's not easy.
Not easy, but...
How would you do it?
Well, you can just attach some code. For example, when your code is invoked, when a method is invoked, or when a method ends. So you can just write some tracing somewhere, and then you can read the mapping that you store.
Thanks. Basically, this is also a great solution that I think it will keep most of the code clean. However, the cost is having this aspect-oriented thing in Android, which of course results in increased method count and etc. But definitely a good way to think about, especially during your testing builds. 3 solutions. Do we have more? Come on, guys, in good consulting company, we have to provide much more solutions. All right, I show you the solution that I have thought about. And the best part is that all the 3 respected solutions before and my solution are totally different, which is good, meaning we're on the interesting subject. So my solution is use a simple logger, but however, you need to implement your own logger and print a thread ID inside the log XX methods. And to make things interesting, we can use annotations to control the logger, to show various things, especially if we want or we don't want to put thread IDs during debug, release, or whatever. And this solution just takes the usual logging solution, because we actually do put logs on the important methods that we want to trace for. Any questions so far? All right. Yeah. The thing is, because I thought about it yesterday night, I still need to write it. But the examples could be is running over the classes, like we have seen before, getting the value of annotation, which is, for instance, showing something in release or showing something in debug, and then doing the ifs or the enum patterns inside the logger. So let's start to recap. All we know, if you use these solutions for custom code generations, we achieve a greater developer productivity. Think of all the developers who are using Retrofit and Dega, how much time they have saved. Think of the exposure of the authors of these libraries. It's really helpful to come over to job interview, and the company that you are interviewing for is actually using your solution. It can increase your chances of getting accepted and getting a higher salary. Not the worst place in life to be. It's really helpful in recruiting, because a company that posts a lot of good open source code can attract better talent. This is also good for community, because you know, we don't know all the guys, both in Google, in Square, and various other companies who wrote software that we are using on a daily basis. So with that in mind, if you have no further questions, let me thank you for your time. I'm here if you have questions now and later during the day, what Michal and David organized with the reception hour or whatever. Thanks again. It's a huge pleasure for me to be here, and enjoy your day. And I put these slides during next week on the slideshow and make sure that Michal, etc., and you guys will get them. Thanks again.